From NRF-SAEON, we have Dr. Tammy, who gave a talk on fantastic robots in the ocean or something. Believe me, that was interesting, but I can't explain it, but she will do a better job. Before we even take it further, can you kindly introduce yourself?
So good day, everyone. My name's Tammy Morris. I'm a Ocean and Polar Coordinator with the SAEON Egagasini Node, which is the offshore node as part of the Environmental Observation Network, and we're based here in Cape Town. I've done a talk here on ocean robots and our way of being able to observe the ocean and to try and understand this as the ocean changes, but also to try and understand this and how it impacts society.
Okay, so what exactly are these robots?
So they're autonomous instruments, and we work with a fair number of different types. So the first of these is an Argo float, which sinks down to about 1,000 meters, and it stays there for about 10 days. It then sinks further to 2,000 meters and then profiles all the way to the surface and gives us the data via satellite. And within 12 hours, that data is made available to forecast systems and all sorts of global model systems so that we can try and understand the state of the ocean. And we have about 4,000 of these robots globally, which are deployed by various nations around the world. And this is our collective effort of being able to understand the state of the ocean, how it's changing, sea level rise, and things like that. And then we also work with ocean gliders that are working on a similar concept, but we're able to pilot these and direct them to where we want to be studying certain areas of the ocean.
Is there anything interesting that these robots are seeing? Are there any mermaids down there?
Sadly, there is a mermaid float. Sadly, we haven't picked up any mermaids just yet, but some of them have the capability of being fitted with sort of biogeochemical sensors and looking at the carbon within the ocean and understanding where there's heats or where there's sinks and sources of carbon. We look at some of the phytoplankton through fluorescence and things like that. So we're able to at least understand a bit more, not just the physics, but also a bit of the biology, a bit of the ecosystem understanding of the ocean. So they're very interesting.
Okay. So what kind of data are these robots bringing to the surface? Is it images? Is it numbers? Do we code to get information from this data?
So primarily it's things like pressure, temperature, and salinity, which you think, oh, it's not a lot of interesting data. Sometimes we have oxygen. But when we combine these parameters together, we're able to understand how the ocean is expanding, how it's rising, or if it's not, because in certain places it does different things. And just being able to have this basic assessment of the ocean gives us so much more information about what we can expect, how it's going to intensify storm tracks, how it could be looking at different ways in which the currents are moving and where that warm water is moving towards. And then we've got those additional sensors where we're looking at the actual biology and the chemistry. Some of the Argo floats even have some really interesting imaging devices, but this is more for your like small planktonic species and things like that.
Someone could be asking, oh, okay, so we are funding this thing. How is this even helping us? How is the science going back to the people?
And this is a very important question and something that we strive to make sure that people understand. Without knowledge of the ocean, we'll never understand how weather systems are happening. Think about big cloud systems over the ocean. This is all from evaporation. If we understand how the weather and climate are developing over the ocean, we'll have a better idea of our weather forecasting capabilities. If we're able to understand warmer oceans and the how they impact storm tracks and frequencies and things, we're able to protect society and say, look, there's a big storm coming. You really need to move out the way. It's going to be carrying stuff over. The more we understand about the ocean, and not just the surface, but also the subsurface, the more we're able to protect people. And that's just weather and climate. We look at things, how that would play into agriculture in terms of rainfall, how it would play into marine heat waves, where we've got a concentration of warm water that's going to impact fisheries, biodiversity. So we need to understand the ocean as a whole and as deep as possible so that we can look at all of these smaller aspects because they directly impact society, not just at the coastal regions, but inland as well. All of that, all of that atmospheric considerations, they travel inland and change the way we understand our world.
Wow, this is really interesting. I didn't know, but when you're explaining, it makes so much sense. So, any other last words that you'd like people to know, and your expectation or your highlights so far in the SAASTEC conference?
It's very interesting connecting to people to try and look at how our science can be taken over into the next generation. So through the science centers, through educational teams, how we could be, engaging with the next generation, not just for the sake of marine science, but in terms of engineering, technology, new sensor development, data science. So there's a lot we could be looking at the next generation, and this is a fantastic ambit to try and put that across for us.
Thank you so much, Dr. Tammy, for your side. That is Dr. Tammy from NRF-SAEON.